Welcome to this lesson of Submath Senior 5. We are continuing with the topic of series and the subtopic of geometric progression. I'm Nicholas Busobozi to take you through this lesson. Last time, I introduced you to how we get the nth term of a geometric progression, where we saw that to find the nth term un, we use the expression un equals to ar power n minus 1, where a is the first term and r is the common ratio. So we are going to see how we determine the sum Sn of the first n terms of a geometric progression. So consider a GP with the first term as A and the common ratio as R. So adding the terms of the GP, we shall have Sn is equal to A plus AR plus AR squared plus AR cubed plus AR power n minus 2 plus AR power n minus 1. We call that equation 1. So multiplying equation 1 by R gives R Sn is equal to AR plus AR squared plus AR cubed plus AR power n minus 1 plus AR to power n. We call that equation 2. Equation 2 minus equation 1 gives R Sn minus Sn is equal to AR power n minus A. So this means that R minus 1 Sn is equal to A into R power n minus 1. And making Sn the subject, we have Sn is equal to A into R power n minus 1 over R minus 1. Also, equation 1 minus equation 2 gives Sn minus R. Sn is equal to A minus AR power n, implying 1 minus R Sn equals to A into 1 minus A power n. So therefore, Sn is equal to A into 1 minus R power n over 1 minus R. So as you can see, we have two expressions for the sum of the first n terms of a GP. So when do we use these expressions? The first expression that we got is used when R is greater than 1, when the modulus of R is greater than 1. What I'm saying is that the expression Sn equals to A into R power n minus 1 over R minus 1 is used for modulus of R greater than 1. The second expression, Sn, which equals to A into 1 minus R power n over 1 minus R, is used when the modulus of R is less than 1. When we talk of modulus of R being less than 1, we mean negative 1 less than R less than 1, when R is between negative 1 and 1. Examples. Let us look at our first example. Find the sum of the first 8 terms of the series 3 plus 6 plus 12. If you look at that series, Our first term is 3 and the common ratio is 2. And we want the sum of the first 8 terms. So in this case, since r is greater than 1, then we shall use the expression Sn equals to a into r power n minus 1 over r minus 1. So we shall substitute in that expression and we shall end up getting S8 is equal to 765. So therefore the sum of the first 8 terms of the series 3 plus 6 plus 12 is 765. Our next example. Find the sum of the first 6 terms of the GP, 81 plus 27 plus 9. So looking at that GP, the first term A is 81 and the common ratio R is a third. So in this case, R is less than 1. So therefore we shall use the expression Sn is equal to A into 1 minus r power n out of 1 minus r. So substituting in that expression, we find that S6, which is the sum of the first 6 terms, is equal to 364 over 3. So therefore, the sum of the first 6 terms of the GP, 81 plus 27 plus 9 plus is equal to 364 out of 3. Our next example. In a GP, the sum of the second and the third term is 6. And the sum of the third and the fourth term is negative 12. Find the first term and the common ratio. So looking at what we have been given, the sum of the second and the third term is 6. So what is the second term and what is the third term? The second term is AR and the third term is AR squared. So therefore, AR plus AR squared equals to 6. So if we factorize out AR, we shall have AR into 1 plus R is equal to 6. We call that equation 1. Also, the sum of the third and the fourth term is negative 12. So the third term is AR squared and the fourth term is AR cubed. So this means AR squared plus AR cubed is equal to negative 12. So if we factorize out the common terms, that is AR squared, we get AR squared into 1 plus R equals negative 12. We can call this one equation 2. So equation 2 divided by equation 1 will give us R as negative 2. And when we substitute for R in either equation 1 or equation 2, we get A as 3. So therefore, the first term of the series is 3 and the common ratio is negative 2. Let us look at the sum to infinity of a GP. So let us consider the GP A plus AR plus AR squared plus AR cubed plus AR power 4 plus up to infinity, with A as the first term and R as the common ratio. So using the expression Sn equals to A into 1 minus R power n over 1 minus R for modulus of R less than 1, we have that in the limit as n tends to infinity, when n becomes very big, then R to power n tends to 0. Okay, here we need to note that r is less than 1, or r is a fraction. So if n is very big and you get this fraction to power that big value of n, then the expression tends to 0. So therefore, r to power infinity in this case is equal to 0. So S infinity, which is the sum to infinity, will be equal to a into 1 minus r power infinity over 1 minus r. So S infinity equals to a into 1 minus 0 over 1 minus r. So therefore, S infinity is equal to a over 1 minus r. Thus, the expression to determine the sum of a GP up to infinity is S infinity equals to a over 1 minus r, and this is only true when the magnitude of r is less than 1. Example, find the sum to infinity of the GP 24 plus 12 plus 6 plus 3 plus. So looking at that GP, our first term a equals 24 and r equals to a half. So substituting in the expression for the sum to infinity, S infinity equals to a over 1 minus r. So S infinity will be equal to 24 over 1 minus a half, which is 24 divided by a half, and this one gives us 48. So therefore, the sum to infinity of the series is 48. Another example. Express the recurring decimal 0.35 recurring as a fraction to its lowest term. So 0.35 recurring is the same as 0.35, 35, 35, 35, 35, 35, and so on, which is equal to 35 over 100 plus 35 over 10,000 plus 35 over 1 million plus. So looking at that series, it is a GP with the first term a as 35 over 100 and common ratio of 1 over 100. So we shall substitute in the expression for sum to infinity a over 1 minus r, and this will give us 35 over 100 divided by 1 minus 1 over 100, which is 35 over 100 divided by 99 over 100, and this one gives us 35 over 99. Thus, the fraction is 35 over 99. Exercise. So you have these questions. Kindly look through them and try to work them out. For this and for more information, please visit us at our website www.tricona.sc.ug, or you can email us at info@tricona.sc.ug. Thank you.